Hey there, this video has some more examples to practice with if we're trying to solve radical equations, which are equations that have roots in them. So the order that we want to tackle these problems in is to start with anything that is outside of our square root and move that over to the other side of our equation. And when I say move over, what we're really talking about is using inverse operations, things that will cancel something out. So the inverse operation I can use to cancel out this plus 4 is if I subtract 4. And if I do that to one side of my equal sign, I need to do that to the other side as well, so that we're not changing the value of this equation. Positive 4 minus 4 is equal to 0. That cancels out. And 5 minus 4 is equal to 1. So our new equation we have is x over 6, all inside of our square root, equal to 1. After we've gotten rid of any terms that are outside of the square root, we want to get rid of the square root so that we can deal with the variable inside. And to get rid of a square root, the inverse operation we can use is square both sides of our equal sign. A square root squared cancels out, so we're just left with x divided by 6 on that side of our equal sign. And 1 squared is 1 times 1, which is equal to 1. Now we want to solve this equation for x, figure out what number x equals. And if we want to cancel out a fraction, we can multiply in order to get rid of that 6 that's in the denominator. A fraction just means dividing, and multiplying is the opposite of dividing. So if I multiply this side of my equation by 6 and multiply the other side of my equation by 6, we get our answer x equals 1 times 6, which is 6. Now let's do this example we've got on the bottom. So we need to start with anything that is outside of our radical. And even though there's a minus sign in front of this 3, I do not want to add 3 to both sides of the equation, because that is not the correct inverse operation that will cancel out this negative 3. What this negative 3 means is negative 3 times our square root. When it's written right next to the square root like that, it's a coefficient. So the opposite of multiplying is if we divide both sides of our equal sign by negative 3. Those inverse operations will cancel out, and negative 21 divided by negative 3 is positive 7. So we have positive 7 equals square root of 24x plus 1. Now we're ready to get rid of that square root, which we can do by raising both sides of this equal sign to the power of 2. A square root and a square are inverse operations. They'll cancel out. And 7 squared is 7 times 7, which is 49. So 49 equals 24x plus 1. Now to finish solving this equation, we'll need to do a couple of things. We need to subtract 1 from both sides of the equation so that we can get that plus 1 to cancel out. And 49 minus 1 gives us 48. So 48 equals 24x. And that 24x means 24 times x. So we can divide both sides of our equal sign by 24 to cause those to cancel out. And 48 divided by 24 is 2. So x equals 2. And we'll look at 2 more examples in this video solving radical equations. We want to start with what is outside of our square root, which in this top example would be this -3 as well as this 5. And we're going to use two different inverse operations to cause those things to cancel out. This -3 is just a number that's being added to the rest of our equation, so we can use addition and subtraction as the inverse operations there to cancel out. -3 plus 3 is 0, and if we add 3 to the other side of our equation, 37 plus 3 gives us 40. So now we have 5 times the square root of 12x plus 4 equals 40. And if we want to get that 5 to cancel out, we can divide both sides of our equal sign by 5. So now we have the square root of 12x plus 4 all by itself, and that equals 40 divided by 5, which is 8. Once we have the outside of our square root taken care of, we want to get rid of the square root itself, which we can do by squaring both sides of this equal sign. That gets rid of the radical, and we're left with 12x plus 4 equals 8 squared, which is 8 times 8, which is 64. And now there are two more things we can do to finish solving this equation and get x by itself. We can subtract 4 from both sides, and we'll get 12x equals 60 because plus 4 and minus 4 cancel out. And now we can divide both sides of the equal sign by 12. 60 divided by 12 is 5, so that leaves us with x equals 5. In this final example, it looks a little bit different because now we have radicals on both sides of our equation, but that's all right because if we square both sides of the equal sign, that will get rid of both of those radicals. And let's continue this on another screen so we've got some more room to work. So we're going to square both sides of this equation, and that gets rid of both of those radicals, and now we have 3x minus 21 equals 24 minus 2x. To solve an equation that has variables on both sides, we want to move all of the variables to one side of our equal sign. And we could pick either side to move those variables to. Why don't we move all of the variables over to the left side of the equation? So if I add 2x to both sides of the equation, that causes the variables that we had on this side to cancel out. And if I add 3x plus 2x on the other side, we get 5x. So 5x minus 21 equals 24. And now let's move all of the other numbers, not the variables, to the other side of our equal sign. If we add 21 to both sides of the equation, we get 5x equals 24 plus 21 is 45. And now we can divide both sides of our equation by 5, and 45 divided by 5 gives us 9, so x equals 9.